Alright, so let's go through the Faraday disc where we need to determine which part of the Faraday disc is positively high potential, right? And of course, which part is negative potential. Okay, so first, if I use the idea of Fleming right hand rule, right? So I can safely determine, so using the Fleming right hand rule, your index finger is pointing into the paper. Then your thumb, right, which determine the motion of the rod is upward. Now, of course, your middle finger is pointing towards the left-hand side, meaning that this part of the rod will be positively charged and this part of the rod will be negatively charged. Because we must treat this as the inside of the battery, right? Okay, so I can also use the electrons model to help me explain. So for example, right, okay, I have a rod. This rod is rotating in a circle. Of course, inside the B field. Okay, so imagine that all the electrons, there are electrons in the metal rod. So these are all the electrons, right? Okay, so with this, right, of course, I understand that the electrons are moving in this particular direction. Okay, so I use Fleming left-hand rule to help me determine what is the direction of the force that the electron actually experience. So for example, you use Fleming left-hand rule. So of course, your index finger must point into the paper. Then your middle finger, okay, your middle finger annotate your current, and not just current, it's conventional current. Means that your middle finger cannot point upward. It's not the direction of the electron flow. It's actually the opposite of it. So meaning that your middle finger must point at the bottom, towards the bottom. And of course, if you point correctly, right, your Fleming left-hand rule, your thumb will be pointing towards the right-hand side. So it means that the electrons are actually experiencing a force towards the right-hand side. Of course, after some time, let's just say the rod is right here. Okay, I draw here. Okay, so let's just say the rod is right here, right? All the electrons will actually congregate at this part. So of course, this part will be negatively charged. Not negatively charged, it's like negative potential, right? Okay, then this part right here, right, will be positively charged. Oh, sorry, a positive potential, high potential. So that is how we can also use your Fleming left-hand rule to determine which part of it is actually high potential, which part of it is low potential.